Hello everyone, let's learn about Diffie Hellman Protocol in this lecture. So Diffie Hellman Protocol is all about managing symmetric key. Now before we delve into Diffie Hellman Protocol, let's learn a little bit about the characteristics of symmetric key cryptography. Now let us consider a network of 4 people where all the 4 people are connected to each other and they are using symmetric key for communication over the network. So, for a network of 4 people, all connected to each other, each person will be needing 3 keys to communicate with 3 other person. So, the total number of keys in the network, as you can find in the diagram, is 6. Or you can also say that it is equals to 4 into 3 divided by 2. Now let the network expand itself to say n number of people where all the people are connected to each other. So for a network of size n, each person in the network communicating needs to remember n minus 1 keys and the total keys needed in the network will be n into n minus 1 divided by 2. Now the problem is not only one needs to remember n minus 1 keys, one needs to securely save n into n minus 1 by 2 keys in the network. And moreover, how will the two parties acquire the shared key in a secured manner? So, a solution has been proposed to these problems, and it has been said that let's create a session key which is created for each session of communication between 2 people and is destroyed when the session is over. So Diffie-Hellman is one of the most popular approach for providing this one-time session key for both the parties. Now let us learn how the Diffie-Hellman protocol works. So while I explain the method, I will also be explaining that with an example side by side so you can remember the concept better. So let us assume there are 2 people, Alice and Bob, who wish to communicate over the network using Diffie-Hellman protocol. So they are trying to generate a key using Diffie-Hellman protocol. So first, they choose a very large prime number n such that n minus 1 by 2 is also prime. So in our example, say this n be 23. We are purposely not taking a large prime number just to keep the calculations simpler. So n equals to 23 also satisfies this n minus 1 by 2 to be a prime, because n minus 1 by 2 in this case is 22 divided by 2, which is equals to 11, and 11 is also a prime number. Next, they also choose another prime number g. Now the point to be noted is this number does not have any special constraint like g minus 1 by 2 needs to be a prime also. So we can choose basically any prime and let that prime number g in our case be 13. Now Alice chooses a random number x. Say that x be equals to 2 in our example, and similarly Bob also chooses a random number y and let that y in our example be 3. Now another point is to be noted is this random number can be really a random number. It doesn't matter if it's a even number, odd number, prime number, composite number. Basically any number can be chosen as x and y. Next, an R1 is computed by Alice, which is equals to g to the power x mod n. So R1 in our case becomes 13 square mod 23, or 169 mod 23, which is equals to 8. Similarly, Bob also calculates R2 as g to the power y mod n, which in our case is 13 cube mod 23, which is equals to 12. Next, Alice sends his R1 over the network to Bob. One point is to be noted that Alice does not divulge the value of x. She just sends the value R1 to Bob. Similarly, Bob also sends the value of R2 to Alice, and also y is kept secret from Alice. Next, Alice computes her key as R2 to the power x mod n. Here, the key of Alice has been shown as K Alice. And Bob also computes. Okay, before we see what Bob computes, let's see what Alice has computed. So Alice, in our example, as per our example, has computed 12 square mod 23 or 144 mod 23, which is equals to 6. Similarly, Bob also computes his key as 1 to the power y mod n, which in our example 8 cube mod 23 or 512 mod 23, which is equals to 6. And they get the symmetric key, or the symmetric key is generated. Now the interesting part is that Bob didn't know x, and Alice didn't know y. Still, they computed the same number because the key which has been generated in this case is equivalent to g to the power xy mod n. Why? Because see, Alice computed R1 as g to the power x mod n, and on this R1, Bob computed R1 to the power y mod n. That is, he actually computed g to the power x mod n to the power y, and that and a modulus n has been taken on this number. And similarly, Alice computed her key as R2 to the power x mod n, which is equivalent to g to the power y mod n to the power x mod n. So that in both the cases, it becomes equivalent to g to the power xy mod n. So now the question is, how secure is Diffie Hellman? Say the network is compromised and a hacker manages to steal the value of n, g, r1 and r2. So he needs to find correctly the values of x and y to calculate and verify the key. Now the beauty of this modular arithmetic is a generator with different exponents give the same result. For example, say 3 square equals to 9. 9 mod 10 equals to 9. Again, 3 to the power 6 equals to 729, and 729 mod 10 is also 9. So if you get this value 9, you won't be, even if you know the value of say n in this case, which is 10, and the g, which is equals to 3 in our case, you won't be able to tell that if 3 square gave you 9 or 3 to the power 6 gave you 9. So you will be confused between 2 and 6. So in order to generate the key and to verify that indeed the key that has been generated is a symmetric key, the hacker has to find out both x and y, which is not so easy. And that too, we need to remember that the key is valid only for one session of communication. Next time Bob and Alice chooses to communicate, they will definitely choose different values of g, n, x, y, etc. So apparently the method is quite secured. So that is all about Diffie Hellman protocol. There is a link given in the description box that takes you to a website that contains some MCQ assignments on Diffie Hellman. And I highly recommend you to practice those so you can check how well you have understood the topic. If you like the video, please give me a thumbs up and share with your friends. And if you like to learn more about different CSE topics, you can subscribe to my channel and hit the bell icon. So whenever I upload, you get to know which topics have been done. So that's all for today. Thank you. Stay blessed and stay healthy. Goodbye.